We have a figure. A is the velocity time graph of a body. You can see the vertical axis carries the velocity, which is measured in meters per second. The horizontal axis carries the time, which is measured in seconds. From figure A above, find question I, the acceleration during the initial part of the motion. Looking at this graph, you will see that at the initial part of the motion, the object was accelerating. You can see how the velocity increases with time. That means there's acceleration here. Whereas here, the object moves with a constant velocity. Then here, you can see that the velocity of the object was reducing. That means there was retardation. Question I says we should find the acceleration during the initial part of the motion. Here, since the velocity was increasing with time, that means there's a change with velocity with time. That means the object was accelerating. So we can calculate the acceleration. For us to calculate the acceleration of the object, we are going to make use of any two plotted points on the velocity time graph. We are going to make use of this point. Here we have 3, 6. Then we make use of this other point. We are not going to use the origin 0, 0. We are going to make use of this other point 1, 2. Make use of this. By making use of these points, we can easily calculate the acceleration of the body during the initial part of the motion. The acceleration will simply be the gradient of this straight line. Take solution. Question I. The acceleration is simply equal to the gradient of the line. Let's label this line. Let's call this point O. This is O. Then we call this other point A. We call this one B. Then we call this one C. It will simply be the gradient of the line OA. This will simply be equal to the gradient of this line. We are going to take V2 minus V1. Then we divide by T2 minus T1. This will be equal to, this is the first point, this is the second point. So this is our T2, V2, T1, V1. V2 is 6 minus V1, which is 2. Here we have 6 minus 2. All this is in meters per second. We have to divide this by, take T2, which is 3 seconds, minus T1, which is 1 second. All this is in seconds. So this will be equal to 6 minus 2 gives us 4 meters per second. We have to divide this by 3 minus 1, which is 2 seconds. So this will simply be equal to 4 divided by 2 gives us 2 meters per second divided by seconds. It gives us meters per second squared. We move now to the next question, question 2i. For question 2i, we have to find the retardation during the final part of the motion. Retardation is simply the negative acceleration You see that here, the last part of the motion, there is a retardation because the velocity of the object is decreasing with time. For us to find the retardation, we are going to make good use of any 2 points on the line BC. Retardation is simply equal to the gradient of the line BC. For us to find the retardation during the final part of the motion, we are going to make use of the point. This point, which is here we have T as 7 and V as 6. Then down here we have this point as we have T as 9. Then we have V as 0. Finding the gradient of the line BC, this is our T1, V1, T2, V2. So this will be equal to take V2 minus V1, then we divide by T2 minus T1. This will simply be equal to, we have V2 as 0 minus V1, which is 6. All this is in meters per second. Then we divide by T2, which is 9, minus T1, which is 7. All this is in seconds. This will simply be equal to negative 6 meters per second. Then we divide by 9 minus 7, which gives us 2 seconds. This will simply be equal to negative 6 divided by 2 gives us negative 3. Meters per second divided by seconds gives us meters per second squared. Therefore, the retardation of the body will simply be negative 3 meters per second squared. You can see it is negative acceleration. Question 3i is asking us to find the total distance traveled by the body during the motion. The total distance will simply be equal to area under the velocity time graph. And this will simply be equal to, so if we calculate the area under this graph, it's going to give us the total distance traveled by the object. You will see that this is the trapezium, and for us to calculate the area of this trapezium, we are going to take a half sum of the parallel sides, then we multiply it by the height. So the area will be equal to a half sum of parallel sides times the height. and this will simply be equal to a half times the sum of the parallel sides. We have from here to here is 9 seconds plus from here to here we have a 3, here we have a 7, so we take 7 minus 3, which gives us 4. Or you count, this will be 1, 2, 3, 4, so it gives 4 seconds. Then we multiply it by the height. This is the height from here to here, which is 6 meters per second. This will give us a half times 9 seconds plus 4 seconds. It gives us 13 seconds times 6 meters per second. You can express this as 13 seconds over 1 times 6 meters per second over 1. 2 will go here 1 time, 2 will go into 6 3 times. We are going to take 13 seconds times 3 meters per second. This will simply be equal to 13 seconds times 3 meters per second can be expressed as 3 meters all over second, like this. You can express 13 seconds as 13 seconds over 1. Second will strike off second, and this will simply give us take 13 times 3, it gives us 39 meters. Therefore, the distance traveled by the body is simply equal to 39 meters. Or another way of calculating the total distance, it is simply equal to, we take the area, you can see that this is a triangle, so we take the area of this triangle plus the area of this rectangle plus the area of this other triangle. So let's split them. This is a triangle, so we can call this one I, we call this 2I, then we call this 3I. So the area, the total distance will simply be equal to the area of I plus the area of 2I plus the area of 3I. This will be equal to the area of I is simply equal to a half base times the height. Take a half times the base, which is 3, times the height, which is 6. We take 3 seconds times 6 meters per second plus the area of 2I. 2I is a rectangle. You can see this is 1, 2, 3, 4 times the height, which is 6. We take 4 seconds times 6 meters per second plus the area of 2 of 3I, which is a triangle. The base is 2 seconds times the height, which is 6 meters per second. We take a half times 2 seconds times 6 meters per second. This will equal to 2 way 1 time, 2 going to 6 3 times. We take 3 seconds times 3 meters per second, it gives us 9 meters plus 4 seconds times 6 meters per second, it gives us 24 meters plus, here 2 will strike off 2, we will be left with 1 second times 6 meters per second, which gives us 6 meters. This will simply be equal to 9 meters plus 24 meters. It gives us 33 meters. 33 meters plus 6 meters gives us 39 meters. You can see the result is the same. We are done with the solution of this question. If in case you have any doubts, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.